Hello everyone. Today we are going to look at the inverse of a 2 by 2 matrix. So when you're getting the inverse of a matrix, what do? I've given about 5 steps of getting the inverse, but before that, what is an inverse? I'll give you an example of a number, say number 4, right? So let's say a number 4, alright? So you have 4 here. What is the inverse of 4? So inverse is usually denoted by raised to negative 1. Okay, so if you say like b raised to negative 1, that means the inverse of b. If you say 4 raised to negative 1, it means the inverse of 4. So what is the inverse of 4? The inverse of 4 is 1 over 4. It's the reciprocal of 4. So what does that mean? When you multiply a number by its inverse, you actually get 1. Right? So that's the general rule. And so what happens when you multiply a matrix with its inverse? Okay, what do you get? Alright, so say you have a matrix A and you multiply it by its inverse. What do you get? You get the identity matrix. Remember we said what an identity matrix is? So in case of a 2 by 2 matrix, the identity matrix is 1 0 0 1. That's the identity matrix. In case it's a 3 by 3 matrix, 1 0 0 0 1 0 0 0 1. That becomes the identity matrix for a 3 by 3 matrix. So in this case we are looking at a 2 by 2 matrix. So it's good you know that when you multiply a matrix by its inverse, you get the identity matrix denoted by that letter I right here. Okay, so having said that, so how do we find the inverse of a 2 by 2 matrix? So the first step is to find the determinant of the matrix, of course denoted by that D, right? So that's the first step. You get the determinant. Number 2 is get the minus of all the elements. You're going to see what minus are. Then number 3 is getting the cofactors. Then number 4, you get the transpose of the cofactor, and that's also called the adjoint. Then finally you multiply the reciprocal of the determinant with the adjoint. Okay, I think I've already said what reciprocal is. So now let's do a practical example to find out how to get the inverse. So find the inverse of the following matrix A, and A is 1 2 negative 3 4. So again, just like we did, the first step is to find the determinant. And I hope you remember how do you find the determinant. It's multiplying the elements on the principal diagonal minus multiplying the elements on the alternate diagonal, and you get your answer there. So 1 times 4 minus 2 times negative 3, which is equals to 10. So our determinant becomes 10. So that's easy. We had already tackled that in our previous class. Then you go now to step 2. So step 2 is to get the minus of all the elements. So what is a minor? If A is an n times n, in this case n can represent any number. So that means 2 times 2 or 3 times 3. So if A is an n times n matrix and one row and one column are deleted, the resulting matrix is an n minus 1 times n minus 1. Submatrix of A. We tackled submatrix I think in our first class. Then the determinant of such a submatrix is called a minor of A. So I've actually given an example there. You can see that we have cancelled the top, the row, and the column. Okay, so once you do that, you cancel this row right here and then the column. Okay, when you do that, you get a submatrix, and in this case you get 4. So 4 is just a number. So because it's a number, remember a minor is a number. So a minor is not a what? a matrix, and in case you get a matrix, in the case we are going to be doing it 3 by 3, we have to get the determinant of that submatrix first, but in this case we're just getting a number. Okay, so once we delete that column and the row, okay, where our target element is 1, because we have to get the minus for all the elements in that matrix. So for our first matrix is this one, for our first element is 1, so you just cross the rows and the column, the row and the column where 1 is, and of course when you cross you're going to remain with 4, and this 4 is the one that we have actually written here. So of course you're going to write it in place of where 1 is, because 4 is the minor of 1. Okay, then we go now to the other one, which is 2. So you cross the row where 2 is and the column where 2 is, and of course when you cross you're going to remain with -3, and you can see we've gotten -3 here. So you're supposed to write -3 where the position where 2 is. So -3 is the minor for 2. Then you go to the next one. So you cross, you go, now you're at 3, -3. So you cross the row and the column where -3 is, and of course you're going to remain with this 2. So this 2 becomes the minor of 3. So you should actually write it in the position where -3 is. Then you go to the last one. Now we are at now 1. So cancel or cross the row where 4 is and the column where 4 is, and of course now this is it, and of course you're going to get this one. So you write 1 here. So eventually our minor looks like this. So you write the minus in the places where the elements were, in the corresponding locations or positions where the elements were. So for 1 is 4, for 2 -3, for 3 -3 is 2, for 4 is 1, right there. So now you have gotten the minor of that matrix, because you've gotten the minor of every element there. Okay, hope that's well understood. Then now we go to the next one. Now, having found the minor, you found the determinant, and you also found the minor of our matrix. So the next thing you do is step 3, you get the cofactors. So how do you get the cofactor? Okay, you actually apply the signs to the minor. Okay, now we've already gotten the minor here. So what you do, you apply these signs. In case of a 2 by 2 matrix, you apply these signs on the minor. Okay, so on the corresponding positions of the minor, and I've just shown it very nicely here. So what do? You take this plus, of course multiply it with the plus here, because we have not put exactly a plus here, but you can see this is a positive 4. So positive and positive of course become positive, so 4 will not change. Then what is negative times negative here? -3. Of course negative times negative is positive. That's why we have a +3 right here. Then you go to negative times positive. We have a +2 here. So negative and positive, you get a what? A negative. Then a positive times a positive becomes a positive, so you have a +1 right there. So by that you'll have gotten the cofactors, okay, of the matrix. So far so good. Now we have already done the step 3. Now we go to step 4. So step 4, working out the cofactor transpose. So you want now to get the transpose of the cofactor. So you can see that every step of the way requires the previous step. So now at step 4, we require step 3, because now we are getting the transpose of our cofactor here. So we write our cofactor here. So how do you get the transpose? By changing the columns into rows or rows into columns. So for our first row, which is 3, 4, 3, we write it going down as a what? A column. And for our second row, -2, 1, again you write it as a column, -2, 1. And that now creates our what? Our transpose, our cofactor transpose, which is also referred to as the adjoint. Okay, so cofactor transpose is also referred to as the adjoint. Then you go to step 5. So in this step 5 is actually the last step, and in this last step you actually get the inverse. And how do you get the inverse? 1 over the determinant, or the reciprocal of the determinant, multiplied by CT, and CT is cofactor transpose or adjoint. They're one and the same thing. Okay, so 1 over determinant, we already have our determinant. Remember, we had already passed through this. So if you multiply matrix by its inverse, you get the identity matrix. Okay, so our determinant was 10, if you remember. So we just do 1 over 10, which is right here, multiplied by our adjoint, and adjoint is right here. It's this one. So it's this one here. Okay, our cofactor transpose, or the adjoint, it's this one, pardon me. So it's 1 over 10, which is the determinant, multiplied by our adjoint, which is this one. Okay, so what do you get when you multiply these two? Remember, this is a scalar value, so you multiply 1 over 10 with every element of this matrix, and finally this is what you get. All right, when you multiply 1 over 10 times 4 you get 4 over 10. 1 over 10 times negative 2, you get negative 2 over 10. 1 over 10 times 3, you get 3 over 10. 1 over 10 times 1, you get 1 over 10. And you can simplify them further. Of course, you're going to get 2 over 5, negative 1 over 5, 3 over 10, and 1 over 10. Of course, you can also make them to be decimals, and this is what you actually get. So now, this one is our inverse. That means if you multiply our original matrix, which was actually 1, 2, negative 3, 4, if you multiply this, I'm sure you already know how to multiply now. If you multiply this multiplied by 0.4, negative 0.2, and then 0.3 and 0.1, if you multiply these two, you're supposed to get 1001. You can try that on your own free time and see that you actually get this as the answer when you multiply those two, because remember we said when you multiply a matrix times its inverse, you get the identity matrix, and in this case this is our identity matrix. Now we have done with that. Now let's look at an example here, not exactly related to inverses, but now you can be asked a question like this in the exam, and this says solve the matrix equation for A, B, C, and D, and you're told A3, negative 1, A plus B is equals to this. So these two matrices are equal. So when you hear that they are equal, what should come in your mind is that every corresponding positional element is equal. That means A is equals to 4 on the other side. That also means 3 is equals to D minus 2C. That also means negative 1 is equals to D plus 2C. That also means that A plus B is equals to negative 2. Okay, so we already have A right there. So when we have A, you can actually get B. Why? You can get B right here. So you just substitute so that you'll have 4 plus B is equals to negative 2. We already have A. So if you take this 4 to this other side, you're going to be left with B is equals to negative 2 plus 4, right? Which then actually gives you B is 2. So A is 4, B is equals to 2. Now you're left with now D and C. So in this case now you're going to have D. Okay, we can just rearrange this one right here so that we have now D minus 2C is equals to 3, and you also have this other one, rearrange it, D plus 2C is equals to negative 1. So of course now this is a simultaneous equation, okay, right there. So you can solve this to actually get what D and what C is. Okay, so Now we can decide to use substitution, we can decide to use elimination, we can decide to use another method that I'm actually going to show you later, which is called the Cramer's rule, to actually get D and to get C. Okay, so what if we decide to use elimination method? Okay, if we use elimination, we can actually get this. So we put a plus. If we add, we actually going, if you add D plus D, so we put a plus here in the elimination method. So D and D, you get 2D. Then if you add minus C plus 2C, you actually get 0. So this is equals to plus, so 3 plus minus 1, you actually get what? 2. So divide by 2, divide by 2, so you actually get D is equals to 1. And of course now you can substitute that D to all of the equations, say this one here. So you substitute it there, you're going to have 1 minus 2C is equals to 3. If you take this to the other side there, you're going to have minus 2C is equals to 3 now minus 1, because now when you take it to this other side, that changes. So negative 2C is equals to what? 2. So divide by negative 2, divide by 2, divide by negative 2 again. So you get C is equals to negative 1. So that's how to do that. So see you in our next lesson.